Welcome everyone to this section on web scraping. Web scraping is a general term for techniques involving automating the gathering of data from a website. As you can imagine, there's often websites that have information that you want to use for some other project. However, actually manually going in and copying and pasting the information yourself would just take too long to be realistically possible. So in this section, we're going to learn how to use Python and a couple of Python libraries to conduct web scraping tasks, such as downloading images or information off of a website. In order to web scrape with Python, what we first need to understand are the basic concepts of how a website works. So, if you've already taken a course on just basic web development, you may actually already know a lot of the information we're going to show here. In order to web scrape with Python, what we really need to understand are how the front end of a website delivers information to your browser. And that includes basically three major topics: HTML, CSS, and JavaScript. Now you don't need to technically know HTML, CSS, and JavaScript in depth in order to actually scrape a website. You just need to know enough to be able to understand what your browser is showing you. So let's first just very briefly have an overview of how a website connects to the internet and then how your browser displays information to you. So when a browser loads a website, the user gets to see what is known as the front end of the website. Let's imagine that you wanted to read an article on Wikipedia. So what you do, you open up your computer, you connect to the internet, you open up your browser, and in your browser, you're going to pass in the URL to your Wikipedia article, and then Wikipedia returns back some information to your browser, and your browser displays it in a format that you can read. So this is a human readable format. But really, what Wikipedia is returning is code, such as an HTML document, which stands for Hypertext Markup Language. And this is special code that your browser is able to read and understand in order to display something that looks nice for a human to read. So what we're going to be doing instead is being able to read this HTML and CSS and JavaScript code that Wikipedia is sending back to us, and we're going to use a Python web scraping program to directly grab what we want. Maybe we want to actually grab the Wikipedia logo off of this. So we would be able to search this HTML document and find where that logo's image is, such as a JPEG or PNG file, and then use that for some other project. Or maybe we want to grab some information off this HTML document. Python will be able to do that as well. So we can grab images and information off this HTML document and convert it into another Python object, such as a Python list. Okay, so there's a couple things we need to understand in order to perform web scraping effectively. The first one is actually not technical. It's the rules of web scraping that you should abide by. The second one, also not really technical, it's the limitations of web scraping. So we want you to have realistic expectations coming into this section. And then the third one is more technical. It's just an understanding of basic HTML and CSS. So again, you don't need to become an expert in HTML and CSS in order to perform web scraping. You just need to know enough about them that you're able to actually find what you're looking for in the HTML and CSS code. Okay, so let's get started. First, the rules of web scraping. You should always try to get permission before scraping. If you make too many scraping attempts or requests, then it's possible that your IP address could get blocked, which means you won't even be able to visit that website in a normal browser. Now, if you're dealing with a website that gets millions of visitors, something like Wikipedia, and you're just going to scrape it a few times to get some information, then really that's no problem because that website deals with much, much higher traffic. But keep in mind that some sites do automatically block scraping software. So you should always make sure and check the permissions or rules or guideline page for whatever particular website you're going to be attempting to scrape. So always try to get permission before scraping. And you should also check the laws of whatever country you're operating in to see if it's legal to web scrape. Typically, it's okay, but again, you should always consult the website rules in order to make sure you're okay. The second thing I want to talk about are the limitations of web scraping. And in general, every website is unique, which means, unfortunately, every web scraping script is unique. So you can't really just take one web scraping script in Python and just easily apply it to any other website in the world. Since every website's HTML code is going to be unique to that website, more than likely you're going to have to adjust your script in order to fit other websites. And keep in mind that any slight change or update to a website may completely break your web scraping script. So the scripts in general are pretty static and they're not going to be able to adjust to changes in the website. So this is something that is a little annoying about web scraping, and it's the fact that if you plan to have kind of a long-term web scraping project, then it's more than likely you're going to have to make adjustments to that script over time. But our goal in this section of the course is to be able to generalize the skill set of using Python to perform web scraping so that you can take the general ideas and then apply them to websites instead of having to try to copy some cookie cutter code. So really what we want you to do is become experts in looking up information and generalizing the process of web scraping so you can apply it to unique situations. Okay, now let's talk about the main front-end components of a website. If you're already familiar with HTML and CSS and even a little bit of JavaScript, you should actually be okay for the rest of this and you can skip forward. But if Python is your first language, then you may not be familiar with these concepts. So here are the actual three main components of the front end of a website. Essentially, these are the three things that are being passed into your browser, and then your browser uses this to show you something that's human readable. And Python is basically going to grab these raw documents or this raw code itself and then extract information that it wants from it. So when viewing a website, that browser is not going to show you all that source code. Instead, it shows you the HTML and some CSS and JavaScript that the website sends to your browser, and your browser processes that information. HTML is used to create the basic structure and content of a web page. So HTML actually contains the information that's shown on the website, such as the words written in a paragraph on the website. CSS, which stands for Cascading Style Sheets, is used for the design and style of a web page. So, based off the HTML elements, they'll be connected to some sort of style, such as font size or color or positioning on the website, and that's what CSS does. So HTML, main information on the website. CSS is going to be the design and style of that HTML. And then finally, there may be JavaScript, which is used to define the interactive elements of a web page. And often for our scraping jobs, we won't actually have to worry that much about JavaScript. Really, it's the HTML that we're looking for, and we can use CSS to help us find it. But let's go into a little more depth on each of these. So really, as I mentioned, for effective basic web scraping, we only need to have a basic understanding of HTML and CSS. And what's going to happen is Python can view these HTML and CSS elements programmatically, and then extract information from the website. So let's explore some example HTML and CSS in a little more detail. And don't worry about fully understanding this right now. We're going to see a lot more examples of this when we're web scraping with Python in subsequent lectures. So as I mentioned, HTML is hypertext markup language, and it's present on every single website on the internet. That is essentially the base of a web page. And what's interesting is you can right-click on a website and select View Page Source in order to get an example of what HTML looks like. So we're going to be showing that actual View Page Source later on in the next lectures, but let's see a small example of some HTML code and just highlight a couple of important components. Here we have an example of what a very, very basic website would have for its HTML code. That very top line typically says something like doctype HTML, which is essentially telling whatever program is reading this file, hey, this is an HTML file, so the document type is HTML. And then what we have are various tags or elements. So we have this general HTML tag, and notice we have a starting tag and then a closing tag. And the closing tags of HTML are denoted with a /. So you'll notice that pattern a lot of an opening tag and then a closing tag. And then at the top of an HTML file, we have the head portion. So the head portion basically contains certain high-level information of the web page itself, such as what the title on the browser tab will show, or connections to things like another CSS file. And then we have the body component of an HTML file. And this contains the vast majority of the information that the website or web page is going to display. And we have things like headers, which is bolder text, and things like paragraphs, which is just a paragraph of text information. The main things to understand here is that there's actual tags we can search for. So for some reason later on programmatically, we wanted to grab the text some paragraph from this document, I can notice that it's in between these p tags, which actually stands for paragraph tags. And I'll be able to use Python to look for things that are in between those paragraph tags. So the main thing you need to know about HTML in regards to Python web scraping is the fact that there's an opening tag and a closing tag, and we can look for information between those tags. CSS stands for Cascading Style Sheets. CSS gives style to a website. And what I mean by style are things like changing the colors or fonts or general look of a website. CSS uses tags to define what HTML elements will be styled. Alright, so here we see again a very simple HTML file. However, we've added a connection to CSS and we've styled a particular component or element from this HTML file. The first change you'll notice is that inside the head section, we've actually linked to a CSS file. So we have this link tag and we say, okay, this relationship is going to be style sheet, essentially telling it that this is going to be a CSS file. And then href is essentially the reference for the actual file, essentially telling this HTML document where to find this CSS file, which has things like descriptions on font size, color, position, etc. And now, the way CSS works is once you link to the CSS file, you have things like IDs and classes. There's actually more levels to this in CSS, but for our purposes, we really just need to know about IDs and classes when it comes to CSS. So notice here, inside this paragraph tag that had some text in between the opening tag and closing tag, in the opening tag, I've now have this link to ID is equal to para2. And para2 is an ID call inside the CSS file. And so now that this paragraph tag has a connection to ID is equal to para2, it's going to grab its style choices from the para2 ID inside that .css file. So what does the .css file look like? Well, let's take a look. This is an example of what the style.css file looks like. And it will essentially have this hashtag symbol, para2, and then notice it almost looks like a dictionary here of the property and then the value for it. So it says color red, which means anything tagged or linked to this ID of para2 or parameter 2, whatever you want to call it, is going to be colored red when it's read in by a browser. So what this is doing is it's going to color this some text inside this paragraph with red. And this hashtag symbol is basically denoting that it's an ID. And typically IDs are only used once per HTML document. Now it could have also been a class call. So it could have been class is equal to something like cool or whatever arbitrary string here that links to the CSS document. And then it would look something like this. We would have a dot instead of a hashtag because this is now a class call and class is denoted by a period or dot. And then we have the properties, something like color is red and then the font family is Verdana. Okay, so classes are typically used when you want to add the same style to multiple elements across an HTML file. So think of IDs as typically a one use and then classes as multi-use. So then, in a much larger CSS file, you could have something that looks like this. You could have P, which basically says all paragraph elements in an HTML file are going to have color red, a specific font family, a specific font size. Or we can adjust to something like some class, denoted by the period, and then color, font family, font size, or an ID, which is just going to affect typically one element inside the HTML file, with, in this case, the color blue. So this is what a full CSS file could look like. All right, so I know that was a lot of information that we just threw at you, but don't worry about memorizing this. We're going to see lots of examples, and it's going to be a lot clearer when you actually see how this all connects with web scraping and Python. The main ideas that I really want you to get out of this lecture is the fact that the HTML file is going to contain the information, a CSS file contains the styling information, and then we can use HTML and CSS tags to locate specific information on a page. And the whole idea of web scraping with Python is you're going to point Python to a particular either CSS tag or HTML element and then just grab information based off that. Now, to web scrape with Python, we can use the Beautiful Soup and Requests libraries. And these are external libraries outside of base Python, so you need to install them with either conda or pip at your command line. So directly at your command line, use pip install requests, pip install lxml, which is going to be used with the Beautiful Soup library, and then pip install bs4, which is how we can install Beautiful Soup 4. And I know Beautiful Soup, kind of a strange name, but you'll see why they call it a soup later on. Now, if you're using an Anaconda distribution, you should be able to use conda install instead of pip install. And I'm actually going to install all of these in the next lecture, so you can see what I mean. So let's go ahead and work through some examples of web scraping with Python. Thanks, and I'll see you in the next lecture. Welcome everyone to this lecture where we're going to make sure we're all set up for web scraping. So what we're going to be doing here is we will install the necessary libraries at the command line, and then we're going to explore how to inspect elements and view the source of a web page. Keep in mind, for this second part, we do highly suggest you use Google Chrome as your web browser, because that way you can follow along exactly with us. But if you're using something like Firefox or Microsoft Edge, then you should be able to follow along anyways, because the tools are available in all major browsers. They might just be named slightly differently, but in general, you should be able to inspect elements and view the page source in any browser. But if you're having trouble finding it, go ahead and just use Chrome. Let's get started by installing the necessary libraries. To do this, I'm going to open up my command line. So you can either open up your terminal on Ubuntu or Mac OS, or if you're on Windows, you can open up your Anaconda prompt or command prompt. Let's get started. All right, here's my Anaconda prompt. If you have any issues with your normal command prompt with Windows, go ahead and give a go at the Anaconda prompt. And what we need to do here is we need to install 3 libraries, just make sure they're installed. If you're using Anaconda as your main setup, you should be able to use conda install. If not, you can always use pip install as well. So the first one we're going to install is called requests, which actually allows us to make a request to a website and then grab the information off of it. So you can go ahead and say pip install requests. Notice that mine's already satisfied. Next, what you want to do is pip install lxml, and that's going to be used later on by the Beautiful Soup library in order to essentially decipher what's inside what requests returns. So we'll use pip install lxml. Again, it's already satisfied for me. And then finally, I'm going to pip install bs4, which stands for Beautiful Soup version 4. So go ahead and say pip install bs4. And in this case, we already got it. Okay, so that's it for these libraries. Again, it's requests, lxml, those aren't ones, those are L's, lowercase, and then bs4. You can check out the previous slide in case you need to understand that, and you can also check out the notebook. We have the list that you need to install there as well. So once we have those 3 libraries, we should be good to go in a notebook. We can confirm this by go ahead and you might need to restart your computer, but after you restart, you should be able to open up a new notebook and then import requests. And you should also be able to import bs4. And if you can do that inside of a notebook, then you're pretty much good to go. Okay, so now what I want to do is show you how you can view a page source as well as inspect a particular element inside the Chrome browser. To do this, I'm going to go to a Wikipedia article page. All right, so here I'm at the Wikipedia article page for Jonas Salk, which if you don't know who he is, he actually developed the polio vaccine, saving lots of lives. And now what we're going to do is take a look at the source code that your browser is receiving from Wikipedia and then converting it to something that you can read as a human. So what we're going to do here is go ahead and right-click on the page, and you should see the option to view page source. Now be careful not to accidentally right-click on something that is actually a link, such as here, University of Michigan. If you right-click that, it'll ask you to do things related to the link. Instead, choose somewhere on the Wikipedia article that looks like just general white space, and then you should be able to view page source. There's also a shortcut, which on my browser is Control+U. All right, so if we hit View Page Source, we actually now get this source HTML document inside of a new tab. And we can see that, just like our simple examples, there's doc type HTML, there's this head tag, a bunch of stuff in the head, things like the title, which is what the information goes in the tab here. And if you keep going, you'll see a bunch of different links. And if you keep going further after that, you'll start seeing things like H1 or header tags. And then you can see the ID, class calls, etc. Now, something to keep in mind is when you're web scraping, you're not going to be opening up this huge file and then trying to find something here. That's actually really hard to do given how much information is here. It's definitely possible, and it is part of the process depending on what you're trying to achieve. But in general, what we really want to do is just be able to hone in on a certain section and then see what IDs it might have. So to do that, what we can do is we'll come back to this article, and let's imagine I was interested in trying to grab this image of Mr. Salk. So what I can do is I can go ahead and right click here and then hit inspect. And what inspect is going to do is essentially just going to open and highlight that particular section of that HTML document that is related to whatever I happen to be inspecting, which in this case, if you kind of hover over, it'll highlight, is that actual image. So I can see the image, and then later on we're going to learn how we can actually grab this image, download it, and save it onto our computers. And you can do this sort of inspection for really anything on the page. So for example, if you happen to be interested in the table of contents here, you could right click this, hit inspect, and then you could come here and start looking at what class calls are related to things in the content or table of contents. And you can actually kind of open these and expand these, see that they're a list item, etc. Now, this sort of thing is where it definitely helps to know HTML and CSS. It will make your web scraping a lot easier. So if you do plan to be using Python for a lot of web scraping tasks, I highly recommend that you learn HTML and CSS first, or at least try to boost your skills in that, because it's going to make your life a lot easier when it comes to web scraping, because you'll be able to read this information easily. Okay, so with that being said, there was just a couple of things I wanted to show you here, which was, again, how you can inspect the source, which is right-click, view page source, and then we get this giant source, and then also how to inspect a particular element, which is just right-click and then inspect, and it basically highlights any particular element that we're looking at. For example, we're highlighting this second paragraph, and you can expand on that and then view any links that were there and the actual material itself. And if you really wanted to, you can actually start editing this. So for example, I can start deleting here, and then if I click back, notice it deleted here as well. Keep in mind, I'm not deleting Wikipedia for everybody. I'm just deleting this particular instance of Wikipedia that my browser is reading because I'm editing that source code. Okay, so let's go ahead and explore how we can use Python along with our web scraping skills in order to grab information off something like a Wikipedia article page. I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're finally going to start web scraping with Python, and we'll begin by showing you how you can grab a page title from any website. So let's go ahead and get started by opening up a Jupyter Notebook. Okay, here I am at the Jupyter Notebook. Before we begin, I want to again point out that everything and all the code we show here is inside the notebook that goes along with this lecture, which is called Guide to Web Scraping. And this notebook is going to be used for most of the lectures throughout this section of the course. So I just want to show you here that there's a lot of information that's accessible to you inside this Guide to Web Scraping notebook. We go and break down HTML documents, a little bit of CSS, web scraping guidelines, as well as what to install. And so we're going to start with this example task 0, which is grabbing the title of a page. And we're going to be using example.com for this, which is just a very simple example domain page. All right, so let's go ahead and get started. First, you'll notice that we have this example domain page on example.com. The page title is going to be the text that shows up inside of this tab. So for example.com, that's example domain. For the Wikipedia article that we saw about Jonas Salk, that title is Jonas Salk-Wikipedia. So let's go ahead and show you the process in order to do some web scraping. The first thing we have to do is import request. So that's step 1. And then what we need to do is we need to get a web page through a request. So we say something like result is equal to request, and then we call the get method off requests, and we simply pass in the actual URL. So in this case, for example domain, it's HTTP. It's actually not secure. It's not HTTPS, but you're just going to say http://www.example.com. So this is where you would put in the URL. And make sure to include either HTTP or HTTPS, depending on what the website actually has. So most sites are actually now HTTPS, but keep in mind for some very simple sites, they actually may just be HTTP, which essentially means whether or not they're secured. Okay, so if you get any error on that, you want to double check your firewall and make sure it's not blocking Python from reaching out to the internet and grabbing information. Now that we have this result, let's go ahead and check the type. So we have this request.models and it's a response. So essentially what happened here is the requests library that we downloaded goes and gets a response from www.example.com, and we can actually then call result.text, and it's an attribute. So if I run this, notice that it's actually this HTML document. And if I take a look at example domain and hit view page source, it's essentially this information here just stored as a giant Python string. And this is nice because anything I can do with a Python string, I can now do this large text. However, this is actually just a string. In order to parse through this, what we need to do is use Beautiful Soup. The Beautiful Soup library, which we installed with BS4, is actually going to allow us to then grab and easily obtain information from this due to IDs or class calls or HTML tags. So right now we just have this giant string, and we're going to convert it into a soup. So you can imagine that a soup, you have ingredients that go into a soup, and then Beautiful Soup basically thinks of an HTML document as kind of this giant soup that you can then grab information from, like you could grab ingredients from. So let's go ahead and now import BS4. The next step is to actually create the soup variable. So we'll say soup is equal to bs4.beautifulsoup. And we're going to pass in two things here. We're going to pass in this text string, and then finally a string code for what engine to use to parse through this HTML text. And for this, it's LXML. Notice that I'm passing this in as a string, and these are L's, not ones. And that's why we actually had to pip install LXML, because Beautiful Soup uses that on the back end to essentially go through this HTML document and then figure out what is a CSS class, what is a CSS ID, which are the different HTML elements and tags, etc. So if I run this and now call soup, you'll notice that soup has essentially made this really easy to read, and now it looks exactly the same as the source code we saw in this example.com. So essentially, we went from kind of this raw string to this soup object, and now the soup object is smart enough to be able to grab things based off their tags or elements. So here we can see there's this title, example domain. So now what I want to do is grab that from the soup. And the way I can do that is with soup.select. So we can say soup.select, and this is where you can actually grab things from this HTML document. And for this very first simple example, what we're going to do is show you how you can grab just raw HTML elements. So we're not focused on anything with CSS. Basically, we're just looking for these tags. So things like h1, div, body, things that happen to be in between these sort of less than or greater than symbols. So we have this h1 tag, this paragraph tag, etc. So what we're going to do is we simply say, as a string here, pass in one of the tag names. So the tag we were interested in was up here, which was the title tag. So notice there's an opening title and then a closing title, and in between is what we're really looking for. So we say soup.select, and we can pass in that HTML element tag, and notice it brings back this example domain. So it basically looks through this document and it's smart enough to figure out, okay, where are these title tags? Notice that by default, it actually returns a list because technically there could be more than one tag or element on this page, especially for really complicated pages. So let's imagine that I wanted to grab paragraphs. I could say, instead of title, P, which is the paragraph tag, run that, and now I get a list of all the paragraph tags on that page. So here's one paragraph, and then there's a comma, and here's another paragraph. So this is what you do for just selecting simple HTML elements, is you just pass in as a string the name of the element. So you could do div, body, HTML, P. Let's go ahead and do h1 here. Run that, and I can see example domain. So again, the thing to keep in mind is when you call this, it does include those tags, so that opening and closing, and it also automatically reports back a list, even if there's just a single element that is returned with that result. So because of that, you're probably next wondering, let's go back to title here, how you can grab just the actual text. Because if I'm searching for a title, I probably don't want to actually return this opening and closing title tag. I probably just want the actual text. Well, in this case, I need to grab the first item off of this. So let's go ahead and grab that first item. And now I have that string. So this indexing just grabs that first item off the list. And once I have that, I can use the get text method, which just returns back the string. So let's imagine I wanted to just grab this string here of this domain is for an illustrative example, etc. Then I would say soup.select title, whoops, actually paragraph, so P. And let's go ahead and return this back as some object. So we'll say site paragraphs is equal to soup.select P. So again, this string code matches up with some sort of HTML tag here. And now if I take a look at site paragraphs, as expected, it's a list. So if I want the very first item in that list, I can say, go ahead and index at 0. That gets me back this paragraph tag. And if you notice here, if I check the type of this, this is not a string, it's actually a specialized beautiful soup object, which is why I can do something like call .getText on it. So keep in mind, this is not a string, it's a special beautiful soup object, which then means I can do this, get text, and it returns back this as a string. Okay, so we learned a couple of important things here, and let me just go over the steps briefly. The first thing to do is we import requests. We say request.get, pass in your URL. You may need to double check if it's HTTP or HTTPS. You get back this response, which has this text attribute. You go ahead and after you import BS4, you pass in that result.text along with LXML as the code of what to use to decipher this into Beautiful Soup, which then creates this easy to use soup object. And the main thing we do with this soup object is we just select elements off of it. And so a big part of this is understanding how to use this select code and what to pass in here as the string. Because the rest of this pretty much stays the same for most other websites. Pretty much for all the websites we're going to be working with, we import requests, say request.get, and then we create the soup object. The tricky part here is figuring out what do you pass in into the select string. So this is the kind of where the work happens as far as web scraping is concerned. Everything else before this pretty much stays the same. It's figuring out the different string codes you can pass in here, and that's where it becomes really helpful to understand HTML tags and CSS calls. So to expand on this, what we're going to do is in the next example coming up, we're going to show you how to grab all the elements of a class. Thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to show you an example of grabbing all the elements associated with a class inside of a website. As we previously mentioned, a big part of web scraping with the Beautiful Soup library in Python is figuring out what string syntax to pass into the soup.select method, because pretty much everything before that soup.select method is going to be the same regardless of the website. It's figuring out that string syntax that can be the tricky part. So what I want to do is go through a table of some common examples, and these make a lot of sense if you already know the CSS syntax, since that's where the string syntax is derived from. So this table on the left-hand side shows you an example syntax, and then on the right-hand side basically describes what the matching result would be throughout that soup document. And this table is present inside the lecture notebook. So I just want to briefly go over these. The first row is going to grab every element with a certain tag. And we saw that in our previous example when we grabbed, for instance, everything with a paragraph tag, that is the P tag, or everything with a title tag. Now, if we want to grab everything with a particular ID, so we can do that by saying soup.select, and then we use a hashtag symbol right in front of whatever the element ID is. So in the HTML document, you'll see something like ID is equal to, then some sort of string ID code, and you can use that with the hashtag soup.select, and it will grab that ID element. Similarly, for a class, we do the same thing, except instead of a hashtag, it's a period. And this follows along with CSS syntax if you're familiar with building out a CSS document. And if you want to get a little more complex and look for elements within elements, there's a couple different ways to do this. we can say soup.select something like div span, and there's a space in between those two element names. And what that does is basically it grabs any elements named span within a div element. And you can switch those out for any element names. So essentially it's saying find any elements named on that second string within that first string. If you want to be even more precise, for directly within something, you can use the greater than symbol. And basically what this would return back are any elements named span directly within a div element with absolutely nothing in between. Okay, so all of these string codes are derived from CSS syntax. So I would highly encourage you, if you're having trouble with these, to just learn a little bit of CSS. And again, we have a little bit of guide for you in our notebook. But what we can also do is show you an example of using these. So let's go ahead and do that. Let's show you how to grab all the elements of a particular class from a real web page with Python and Beautiful Soup. I'm going to head back to that same notebook we were working in last time. All right, here I am at the Jupyter Notebook. What I'm going to do is head over to a Wikipedia page or Wikipedia article, and you can choose any major Wikipedia article that has a table of contents for this particular example. What we're going to do here is we're going to check out Grace Hopper's Wikipedia article. And in case you don't know, Grace Hopper is a famous computer scientist. And what we're going to do is, let's imagine for some reason, I want to grab all the strings in this table of contents. So there's a couple of different ways we can do this, but the main way we want to understand is the ability to inspect a particular element on a page and then grab an associated class. Now typically there's more than one class or ID or system of calls you can do in order to grab information off of a web page. But let's go ahead and just get you practicing with the generalized method, which is once you figure out what you're interested in grabbing, go ahead and right click on one of these and then hit inspect. So you essentially right click on what you actually want to grab. And you'll notice that if we take a look at the elements that are returned, it looks like we have a couple of classes here. We have something that says class is equal to TOC number, another one that says class is equal to TOC text. And we can begin expanding on this, and as we go through these elements, you'll notice that they're highlighted in the actual web page. So it's basically telling you what everything is associated with. So for example, if I expand on this list, I see class TOC level 1, some sort of href to retirement. Essentially, it will bring you down to the retirement section of that page. I can keep expanding, and I see the actual text that I want here called retirement, and I see it's associated with the class TOC text. And that makes a lot of sense because that stands for, most likely, table of contents text. So let's go ahead and see if we can use this class call TOC text in order to grab all the strings that are in the table of contents. So let's begin by heading over back to our Jupyter Notebook, and let's create a new request. So I'm going to say res is equal to requests.get, and then I'm going to pass in the full URL. So let's go ahead and just copy and paste this here. And there's the full URL. I need to include this HTTPS. So we'll go ahead and make that request. Again, make sure you don't have any firewall or any sort of internet issue that's blocking this request. And then we make a soup out of the text from that request. So we'll say bs4 is equal to beautiful soup res result.text, and then we tell beautiful soup to use lxml in order to decipher it. We run that, and now we have our soup. So if we check out the soup, it's going to be quite large because there's a lot of stuff in that Wikipedia article, but we can see here it's basically grabbed the entire contents from that page. Okay, so now it comes time to figure out what to select from this. So obviously this may take some experimentation, but we already saw when we were inspecting elements that this TOC text class looks like a good contender. So what I want to do is say soup.select and then pass in the appropriate string code. And because we're working with class equals, that means the first one should be a period or dot, and then I'm going to pass in the class name. So it says class is equal to TOC text. So let's pass that in. TOC text. I run that, and here I can see all the spans that have that particular class call, TOC text. So it starts off with early life and education, career, World War II, etc. So it looks like we're actually able to use that class call in order to grab all the information or the strings off this table of contents. And you can do that for essentially anything that's linked appropriately with a class call on this web page. So we're going to come back here, and let's imagine that I actually just want this text, not the span and class call. So recall, we can actually then loop through this and grab the text attribute from these items. So for example, that very first item here, if we check the type, recall it's a specialized Beautiful Soup element tag. It's not just a normal Python string. So if I say my first item is equal to soup.select at 0, then I can see first item here, and after I've go ahead and define it, I can say dot tab, and I can see all the various attributes and method calls here. And pretty much the one we're most interested in is just grabbing the text. So that's a text attribute that's available to us, which just returns the text in between those span calls, early life and education. Which means if I wanted to print out all those strings, I could say for item in soup.select, and then we'll say TOC text print item.text. We run that, and then we get to see the results. All right, that's it for this lecture. Coming up next, we're going to keep continuing with the examples, and we're going to show you how to grab an image from a website and then save it to your computer. I'll see you at the next lecture. Welcome everyone to this lecture where we're going to show you how to grab an image from a website, again using Python. So now that we understand how to grab text information based on tags and element names, I want to explore how to grab images from a website. Images on a website typically have their own URL link ending in something like .jpeg or .png. Beautiful Soup can then scan a page and locate the specialized HTML image tags that essentially denotes where that URL is being linked to. And then Beautiful Soup can grab this list of URLs, essentially grabbing all the images on a web page. Then we can download those URLs as images and write them to the computer. Keep in mind that you should note that always check copyright permission before downloading and using an image from a website. We're going to go ahead and use images from Wikipedia, which are open source. So let's go ahead and open up our notebook and check out a Wikipedia article. Okay, here I am back at the notebook we were using previously. For this example, I'm going to be using the article on Wikipedia for Deep Blue, which is a very famous chess-playing computer. And what we're going to do is see if we can grab the images off of this particular web page. So notice that there's actually two images here that are in the article. One is this picture of Deep Blue, and then one is of Kasparov playing in 1985. And those look to be the main images on this particular page. So first thing we need to do is make a request to this page, turn it into a soup, and then using our skills with the Chrome browser, inspect these actual images and see what we should be looking for as far as either a class name or an element tag. And keep in mind there's usually more than one way to web scrape the same information off a page. The last thing I want to note here before we get started is there is actually a Wikipedia article that describes different things about images on Wikipedia. And most images used on Wikipedia are actually part of Wikimedia Commons. And keep in mind that even if you do see a picture on Wikipedia, there is a chance that it could be copyrighted in some way. So you should always be careful of that. And you should keep in mind that basically here, we're just going to download these images, and I don't plan on reselling these images in any way. So we should be okay from a copyright standpoint. But keep in mind, if you're going to be doing something like downloading these images and then selling them as your own, you should be extremely careful because you may be violating some sort of copyright. So you can go ahead and just Google search 10 things you may not know about images on Wikipedia, and it describes a lot of things that are important to understand about images on the website. Okay, so what we're going to do here is we're going to come back to this Jupyter Notebook, and let's make a fresh request. We'll say res is equal to requests.get, and then I'm going to pass in the URL for this Deep Blue chess computer. You can just copy and paste this from the lecture notebook if you want. And then let's go ahead and make a soup out of it. Say soup equal to bs4 dot beautiful soup. Pass in the resulting text there, and then use LXML as the library. And then if you check out soup, there is our HTML document. Okay, so what we need to do is figure out what we're actually going to use for this soup.select. And typically there's more than one option. If we take a look at these images, what I'm going to do is right click and inspect them. And I can see there's a bunch of different information here. One is that I noticed there's an IMG image tag. And notice here that it's colored differently than other things like classes and IDs because it's an HTML element, just like a div is or just like paragraph is with P. So what I could do is try to just grab everything with IMG. So I come back here, I could just say IMG, and I just pass in IMG because it's an HTML element tag. It's not a particular class or ID, so I don't need to worry about hashtags or periods. Okay, so you can see here, I get back this list of everything that has this image tag associated with it. Now keep in mind, this could be more than the actual images within the article. So you'll notice that within this information, let's go ahead and grab the first one so we can explore it easily. There's this alt, which basically means if the image can't be found, go ahead and show an alternative. The main thing we're looking for when we're dealing with images is this right here, SRC, which essentially tells this tag what is the source of the image. So each image on a website is going to have its unique URL, and you can kind of tell because they'll typically end in something like PNG or JPEG or some sort of image file. So here I can see this symbol, support, vote, etc. So what I'm going to do is I can simply copy the string here that's in source, not with the quotes, just everything in between those quotes. I'm going to copy this and I'm going to paste it into my browser. And when I paste into my browser, it kind of looks empty, but if you'll notice, at the very center, there's this green plus sign. And that's because on the actual Wikipedia article, there's more images than just this image of Deep Blue and of Kasparov playing chess. In fact, there's an image here for different articles on chess programming. There's an image here for the Wikipedia logo. There's the little image here for this person. And there's an image here for this plus sign. So there actually could be images all over this page that are outside of the article. There's a little settings tool here. There's a little star, etc. So just choosing all images may actually not be specific enough. It's definitely a good start if you're having trouble finding the particular classes or ID calls on a page, because for sure, these two images are going to be within image tags. But let's imagine I just want images that are within the article. I don't want every image on the page. So I'll have to be a little more careful in my inspection, and I will simply inspect the image that's within the article and see if I can hone in on maybe a class or ID. And if you start looking closely, you'll notice that within this image, there is actually a class, and it says class is thumb image. So what I'm going to do is see if I can just select everything with a thumb image, and if that's the right class call for images that are within the article and part of the article, not just an image on the page. So instead of selecting all images, I'm going to try to select that class call of dot thumb image. And again, I'm using this dot here because it's a class. I run this and it looks like I have two links, which is already looking good for us because I know there was really only two images within the article itself. So let's confirm this by just grabbing what's under source, SRC, going to copy this, and let's paste it into our browser. And we can see here that it worked for the first one, and let's confirm the second one. So again, I'm going to grab the second source here, copy this, paste it in, and it looks like that's also the correct corresponding image. So it looks like the right call here was to be specific enough to a class instead of just grabbing everything with an image tag. This is something you'll have to experiment with depending on what website you're working with, as well as what your final goals are. But let's imagine my goals were just to grab those two images that were within the article. Perfect. So now that I have that, what I'm going to do is check out the image information and see if I can download it. So let's go ahead and grab the image of the computer, which was the first one. So I'll say computer is equal to soup.select. We're going to say thumb image, and let's just grab that first image. So there's the computer, and we have this information here. And what I want to do is actually just want to grab a particular portion of this. Notice you have something like class equals, data file width equals. source set equals, source height equals. If you're looking for just a particular aspect or parameter call here, what you can do is almost treat this as a dictionary, because recall, computer is not a string, it's a specialized tag object. And because it's a tag object, it means you can actually do a call like a dictionary for any particular part of this tag. So if I said class, it would return back thumb image. And that means if I said source, which is what I'm actually interested in, it returns back this string. So this string is what I actually want to download. And one real quick way we could just link this to a notebook is if I copy this string, select a cell, and say cell type, markdown, what I could do is actually paste this within my own image tag, because Markdown actually supports these image tags. So I could say img source equal to, and then pass in as a string that source. So here what I'm saying is image source equal to, and then this giant string, and then what I'm going to do is close it off, hit enter, and what this markdown cell actually does is it grabs that URL and then displays it inside the notebook. So if that's something you want to do within your own notebooks, it's kind of a fun little trick. And again, the tricks for that were to take cell type, turn it into markdown, and this essentially supports just basic HTML, where we have this image tag, source, and then the JPEG. Keep in mind though, if this link ever changes, then the notebook will disappear, or it'll essentially make something broken. So let's say they change it, or you accidentally spell this wrong. So I'm just going to say deep.jpg, run this, you'll get this little broken image sign. Okay, so I'm going to go ahead and delete that cell. Now, because we don't want to be dependent on this website, let's imagine I want to download this, maybe for a school presentation or something like that. What I can do is make a new request specifically on this URL. So let's go ahead and do that. What I'm going to say is image link is equal to requests.get. And now I'm just going to pass in this link itself. So copy and paste that. And what I need to do is in front of this add HTTPS. So I'll say HTTPS colon and then the full link. So essentially I'm making a request on this specific link, which is the link, if we put this in our URL, for the computer. So if I were to copy this here and paste it, I can see that this is what that code is going to make a request for, just this particular image. So we go ahead and run this. And now I can say image link, and this is going to have a content attribute. And what this is, it's the raw content of the actual image. So this is a binary file. And this is the computer's way of representing internally what this image actually looks like. So this is actually kind of not readable by a human. This is a binary file. However, Python is smart enough to be able to read and write this file and save the image onto your computer. And we do this by opening a new file and then writing to it and then closing to it. So recall that this imagelink.content has the information I need, and now I want to save this onto my computer in the form of an image. And the way we do that is I say something like f is equal to open. Go ahead and choose your file name. So I can say my computer image.jpg. Typically, you're going to want to make sure that this ending matches the ending of your URL, which was JPEG. And then for the writing or reading permission, so recall the actual mode we're going to be doing, it's going to be WB, which means write binary. So it denotes binary writing because that's not a typical string or text file. It's actually a binary representation of that image. So we're going to open up this new JPEG image, which I just created through the open command. So recall, this essentially makes this JPEG file for us, and then what we're going to do is say f.write image link content. So now I went ahead and wrote that to this JPEG that we just created, and then I'm going to close. There we go. And so now you should be able to see locally this JPEG file. So if I hit File Open, scroll down here, I was working with this untitled notebook. Notice now I have this mycomputerimage.jpg, and this is going to save wherever your notebook happens to be located. If you want to save this somewhere else, then simply provide the full file path of where you want to save it. So you could do something like C users / etc. So depending on what computer and OS, you can save this technically anywhere on your computer. If you just say JPEG, it'll save it to the exact same location your notebook is in, which you can always confirm with PWD. Okay, so let me delete that. So we have this My Computer image. If I click this open, notice it downloaded the actual image. And now we have it written on our computer. Okay, so that's an example of downloading images. So let me just do a quick overview of everything we did here, because it was quite a bit. We went ahead and made a request on a website, turned it into a soup, and then we had to select a particular tag or class call. If you just do image tags, they'll grab all the images on the page. If you're looking for something more specific, see if you can find a class call or an ID call to further specify your results. After that, we can go ahead and confirm the source by just grabbing this and pasting it into our browser, confirm that's the image we want. Once we know the actual URL for the image we want, we go ahead and make a request on that image URL. Then we can open it, write it, and close it. And the thing to keep in mind about opening it is that it should be write binary, or WB mode. All right, up next, we're going to show you an example project which is working with multiple pages and items. So a little bit more of a realistic task. Thanks, and I'll see you at the next lecture. Welcome back, everyone, to this example project where we're going to be working with multiple pages and items. Keep in mind, we're still working with the same lecture notebook guide to web scraping as we did in the previous lectures. Basically, we've already seen how to grab elements just one at a time, such as a couple of images off a single Wikipedia article. But realistically, we want to be able to grab multiple elements and most likely across multiple pages of a website. And this is where we can combine our prior Python knowledge with the web scraping libraries to create really powerful scripts that are heavily customized to whatever task we're trying to achieve. We're going to be using a website specifically designed to practice web scraping called www.toscrape.com. We're going to be practicing grabbing elements across multiple pages. Let's go ahead and get started. I'm going to go back to Jupyter Notebook. Okay, here I am at Jupyter Notebook. The website we're working with is called toscrape.com. It's a website specifically designed for people to practice web scraping on, so we don't need to worry about asking for permissions. And so there's two different websites. One is called Books, and then one is called Quotes. Quotes is what you're going to be working with for your project later on, your exercises, but we're going to practice with this Books website. It's a fictional bookstore, and it's available at books2scrape.com. You can also just click on the image, and it will take you directly to books2scrape.com. And basically what this is, it's kind of like a fake bookstore website. It has a list of books here. We can add things to our basket. There's prices here, and then if we click on a book, it'll take us to the information, what price, how much is in stock, the star rating, and then it says warnings, the demo website. Basically everything's kind of randomly assigned. It has a product description, product information, and so on. So there's lots of different tasks you can play around with here, and I would encourage you, after you work with us on this multiple page scheme, that you kind of pick your own task and see if you can practice with your new skills. But what we're going to do is let's try to get the title of every book that has a 2-star rating. So I'm going to write down our goal here in the notebook. So our goal, get the title of every book with a 2-star rating. So that means we're going to have to be doing a lot of inspection on this website to figure out what particular class calls to use. Now the first thing I'm going to do here is import requests and import BS4, since that's what we're going to be working with. And the second thing I have to realize is if I scroll down here, notice it says 1000 results showing 1 to 20. So that means if I scroll down, that this is actually page 1 of 50, which means I hit next, and notice there's another page to this catalog. So what I need to figure out is how can I use Python and possibly some sort of looping system in order to keep going through each of these pages and keep doing the web scraping necessary. because it's not all just existing on one page, as we previously saw with Wikipedia articles. So the first thing to do is figure out what sort of URL procedure is happening when I go from one page to the next. And if I actually copy and paste the URL just so I can see what it looks like, I'm going to paste it as a string here. Notice that it's bookstoscrape.com/catalog/page dash and then the number inserted there. So that means it looks like a good idea would be to loop and insert a string version of a number. And in this case, I know it goes all the way to 50. Later on in your exercises, you'll have to think of how to use a while loop for when you don't know the last page number. Okay, so we already know that something we're going to have to do is we're going to have to go throughout these pages and possibly fill in that number. So note here, it looks like page 3 follows that same pattern. So page 3, page 2, etc. One thing we have to check is the home page. So let's go ahead and make sure that this works with page 1. So I'm going to come back to the home page here, and I'm going to fill out that 3 with a 1. And that, in fact, does bring us back to the first results, 1 through 20. So it looks like we're good there, which means I just need to figure out how I can make this flexible so I can fill in this number with a string. Well, something I can do is just use the .format method. Lots of different ways you could solve for this, but what I'm going to do is I'm just going to have a base URL, going to copy and paste this string, and then instead of a number, I'm going to fill this in with curly braces. And what's nice about this is then I can say base URL .format, and then whatever I want to insert into that format will show up. So I can say, let's go to page 20, I run that, and it will automatically fill in 20. So that means if I'm looping something such as a number, so I can say page number is equal to page 12, then I can just pass in that page number and it will work. Okay, so again, we have this base URL, and now I figured out a way to conveniently go to any particular page, or as you can imagine, I could loop over some range of pages since I know this goes from pages 1 to 50. Okay, so we figured out that problem of this base URL and then how to continue grabbing elements from it. Next thing I need to do is figure out how to scrape every page in that catalog using that loop, and then figure out what tag and class represents the star rating. So we'll come over here to products, and probably the easiest way to do this is begin inspecting these actual stars. So this may be a little tricky because these could be images. Let's go ahead and check this out. I'm going to inspect these icon stars, and notice here on the inspect, it looks like I have icon star, icon star, icon star, icon star, icon star. So everything is rated out of 5 stars. So I have this little list here of 5 class icon stars. And if I take a look at another one, going to inspect this second star, that it looks to appear the exact same list. So what I can't do is somehow figure out if a star is kind of filled in or not. That's a little trickier. But what's nice is there's a class above this which actually gives the rating. So this is star rating 1 class. And if I take a look at this 3-star book, inspect that again, this says star rating 3. And recall our goal is to grab every book title of a star rating of 2. So let's scroll down here and see a 2-star rated book, Starving Hearts. I'm going to inspect this. And it looks like the class I'm looking for is called star-rating 2. So this is great. I already now know what the class call I'm looking for is. The other thing to keep in mind is that I'm not just looking for the 2-star rating, I'm looking for the associated title. And it looks like all of this is contained within a product class. So if I highlight product underscore pod, then I have this little pod that's holding all this information for this particular book. Looks like it's holding the price, whether it's in stock, the image of the book, as well as the title. So probably what I want to do is just grab this entire little product pod for everything on that web page and then filter out based off this star rating 2 class. So let's begin by grabbing everything on just the first page that contains this product underscore pod class. Now that we know what class we're looking for, let's go ahead and create a request and grab that particular class from the soup. We'll come back here, I'm going to say res is equal to requests.get. And let's just do it from the first page. So we'll say base URL. And I'm going to format in 1. That can be an integer or a string. It should still work. There's our request. Let's turn it into a soup object. We'll say bs4, beautiful soup, pass in the text from that request, and then the engine we use to decode this. And if we take a look at our soup, looks like everything's there. And let's select that class call, which if we take another look, it was product underscore pod. And this dot denotes that it said class equals product pod. We run this, and let's take a look at the length of this. So I'm going to say length of soup.select product pod, and it equals 20. Now we have to ask ourselves, does that make sense? Well, if you take a look back at the website, it said it's showing results 1 through 20, which means it does confirm that most likely each of those product pods went with one of those books. You have to do a little bit of checking just to make sure, but we're pretty much on target that each of those little product pods has information. So what we're going to do in part 2 of this lecture series is continue right where we left off and finish this up by adding in Python code that allows us to explore this soup further, as well as then loop through the different pages on that website to create a list of all the titles that are 2-star books. Thanks, and I'll see you at the next lecture. Welcome back, everyone. As you recall previously, we figured out that we were most interested in selecting this class called product pod. So really what I need to do is figure out what Python code is going to be necessary to grab a title if the actual class is associated with a 2-star rating. Because recall, our goal is get the title of every book with a 2-star rating. And now I essentially have a list of this product pod. So let's go ahead and set this up as a list. So we'll say products is equal to soup.select product pod. And from this point on, there's kind of a million different ways you could do this. So this is just one example of how you could do this. What I'm going to do next is say products 0, and let's just set this up as an example, because if we can get this working for one example, then we should be able to continue exploring this. So here we have this example object. So I take a look at this example, has an article class, looks like it has this class star rating 3, and recall the one we're going to be looking for is star rating 2. So the two things I need to know is this particular class call, whether or not it's star rating 2 or something else, and then the second thing I need to know is this title, which the title is going to be here, A Light in the Attic for that first book. Let's begin by trying to answer the question, is this rated 2 stars or not? There's two different ways you can do this. There's actually probably more than 2 ways, but I'll show you 2 in this lecture. One is kind of a quick and dirty way, which may not always work depending on the situation. And the second one is using Beautiful Soup's select call to actually find this particular class call. So let me show you the quick and dirty way first. So we have this example, it has all the information here. What I could do is convert this to a string, which then makes this into kind of a squashed down string with Python. And you'll notice there's this class call. Class is equal to star rating 3. So something I could do is, because this is a string, I can simply just check is star rating 2 in string example. And I run that, happens to be false. Now recall this first book was rated 3 stars, so let's confirm that. Is star rating 3 in string example? And that happens to be true. So this is kind of just a quick and dirty way to check if something is present in that particular example. So this is one way of figuring out whether or not something is rated 2 stars or something else, because it will just simply return a Boolean. So that's kind of the quick and dirty way. Depending on your website and your application and what question you're actually trying to answer, this sort of method may not be available to you. So now let's kind of go through a more official tactic, which is specifically trying to find what this particular class is. It's checking, is this class present? So I know that the class I'm looking for is called star rating 2. So what I can do, since this example is that specialized Beautiful Soup tag object, I can say example select, and now I can select classes from this. So I could select that star rating class. So I'll say star rating 3, run this, and notice here that there's a space. Because of that, I need to actually fill that in with a dot. And now I should see the correct result. So keep in mind, if you're selecting a class call and there happens to be a space in it, you should be using this dot in order to fill out that space. So now here I can see that there is something returned for that particular class element. If I were to try to search for something that was incorrect, such as star rating 2, run that, then I get back an empty list. So something I could do is just check whether or not I get an empty list when I ask to select star rating.2 from that particular item or product. So again, two different ways I could do this. One is kind of the quick and dirty string check. Check if the star-rating2 string is within the string version of example. The second version is using Beautiful Soup, where I can actually check, hey, select whatever particular class I'm looking for and check to see if it's present. So then I can just simply do something like check if an empty list is equal to this. Because I know if it's going to be empty, then it's not rated 2 stars. Okay, so now that we have those systems in place, I know how to check if this particular product is rated 2 stars. Next, what I need to do is actually figure out how to grab the title of the book. So let's imagine that this returns true and I'm ready to actually select for something that's 2 stars. Depending on how I ran this, I need to grab the title. So let's run the example again and look for where the actual title is. The title may be present in multiple parts. You'll notice here that there's an alternative link inside this image that is just the title of the book, but let's look for something more official. It looks like the official posting of the title is actually here, in title is equal to a light in the attic. And that is held within this tag. So what I'm looking for here are these open and closing tag notes to try to find where this actual information is. So it looks like I have a light in the attic as a title part of this A element, which is essentially a linking element. So what I can do is say example, select A, and here I get back these references, and the one I'm looking for is actually the second link reference. This first one is the image of the book. The second one looks like it's the title. And if we go back to the product page here, notice that both this image and there's a link here will actually lead me to the book page. So that's essentially why there's two links. One is that image and one is the title of the book. Notice that the title parameter is the full title of the book. The text that's actually shown looks to be cut off. So I don't want to operate on this text. Instead, I want to operate on this title parameter. So that means for each product, I'm going to grab the second link at index 1, because at index 0, that's the actual image. Index 1 is going to be the title of the book. And I'm not looking for the text in between these tags. Instead, I'm looking for the title. And as we previously mentioned, I can grab this. If we take a look at this type of object, it's still that specialized BS4 element tag, which means I can grab those parameters as if it was a dictionary call. So I can ask for title, and here I get a light in the attic. So let's just go ahead and kind of mark this down as our notes. So we already know that we can check if something is 2 stars, either through a string call, that in something, or through example select, whatever that rating happened to be. And I know I can use example.select A, grab the second item, and then grab title from that tag to grab the book title. So I have the 2 checks that I need in order to grab a book title if it's 2 stars. Now, all I need to do is give this a shot by combining these ideas that we've talked about with a for loop to loop through all the pages by inserting this format for pages 1 through 50. So let's set that loop up. Shouldn't be too hard. What we're going to do here is say my 2-star titles is equal to an empty list to begin with. And then for n in range 1 up to, but not including 51, because I want pages 1 through 50. My scrape URL is going to be equal to that base URL, and then I'm going to insert that particular number. I'm going to make a request. So we'll say request.get that scrape URL. Then we'll say soup is equal to bs4, beautiful soup, make sure I spell that right. Pass in the text, and then use LXML as my engine there. And then recall my list of books is going to be off that page, select product underscore pod. So recall this books is the same as that list of products I had here. So I'm just calling it books inside this loop. So this books contains all those products, and now I need to filter out through those books. So here's a list of books, which is those element tags for all the books. And I want to say for book in books, I need to check for two things. I want to check if it's 2 stars. Different ways I can do this, but kind of the more official way would be if I grab that book and attempt to select the star rating class, star rating 2, and if that returns an empty list, meaning the length is 1, then, or excuse me, the length is 0 if it's an empty list, then I know star rating 2 is not there. So let me explain this one more time here. What I'm doing is for every book that's returned inside soup.select.productPod, I'm going to attempt to select star rating 2, as we did kind of up here. Here we're selecting star rating 3, and then if I were to select star rating 2, I get back an empty list. So if the list is not empty for star rating 2, that means I do have a 2-star rating book. So what I'm going to do is check the length of that list and make sure it's not empty. That's one way I could have done this. The alternative way was to do that string check. I could have said if star rating 2 in the string version of that particular book. So that's the same as that string example. So this is one way to do the check. This is another way to do the check. Depending on your situation, you may find one better than the other. Okay, so if the length of that selection is not equal to 0, then boom, we have a 2-star rated book, which means the next thing I need to do is actually grab that book title. And we already know how to do this. We'll say book title is equal to, and recall we did this through this example.select A1 title. The only thing I need to do is when I copy and paste this code is this example is now called book. So we're going to replace that with book, and then our 2-star titles, I will append that book title. There we go. Let's go ahead and run this. And if you get some sort of error, go ahead and make sure and copy and paste our code or run our unedited notebook first. If you get some sort of no response error, then you should double check your internet connection and make sure you don't have a firewall blocking you. This site is designed to be scraped, so it's highly unlikely that the site itself is going to be blocking you. Other sites, if you try to run this sort of thing, may block you if you're making too many repeated requests, so keep that in mind. All right, so that finished running. Let's go ahead and just do a very brief overview of everything we did. We went ahead and said for n in range 1 through 51, because I know there's 50 pages, I'm going to scrape that particular page, make a request, turn it into a soup, look for all the product pods, or essentially the books in that soup, and then for each of those books, I'm going to check if it's rated 2 stars by checking to see if something's actually returned when I ask for book select star rating 2. If it happens to be true, I grab that book title and I append it to my list. And so we're going to say 2-star titles. We run this, and now we have a list of all the 2-star books across all the pages. All right, so you should now have the tools necessary to scrape kind of any major website that interests you. And keep in mind, the more complex the website, the harder it will be to scrape, and you should always ask for permission. You should also keep in mind that not every website lends itself this easily to web scraping. Lots of sites nowadays proactively attempt to block people scraping, especially if they feel that the information on the website is proprietary in some way. Okay, so with this new skill set, what we're going to do is set you loose on some exercises. Coming up next, we'll have a brief overview of those exercises, and after that, we'll code through some example solutions. Thanks, and I'll see you at the next lecture. Welcome back, everyone. It's now time to test your new skill set with web scraping with some exercises. In this lecture, we're just going to give a brief overview of the exercise questions and what they're asking for, and then in the next series of lectures, we'll go ahead and work through some example solutions. Let's get started. Okay, so here I am under the web scraping exercise notebook. It's called the web scraping exercise, and essentially we just have a list of tasks for you to complete. So first thing to do is import any libraries you think you'll need. And then the second thing is to use the request library in Beautiful Soup to connect to quotes.toscrape.com to get the HTML text from the home page. So if you click on that link, it'll take you to this Quotes to Scrape. It was essentially the other ToScrape site. So we looked at books, scraping that site in the previous lectures, and now we can see that we have some quotes to scrape. So essentially this site, a couple things to note here, there's quotes to scrape, there's a quote, the person who said the quote, and then tags for each quote, such as change, deep thoughts, etc. And then there's the top 10 tags over here on the right-hand side across the entire site. So you can scroll down here and see that you can click next, and that brings you to the next list of quotes by some authors. And you can also click on about, and that takes you to an about description for those authors. If you click quotes to scrape, that takes you back to the home page. And if you click on one of these tags, such as inspirational, it shows you any quote with the tags inspirational. And then you can always hit next to keep going for whatever pages of those tags for inspirational are. Coming back to the exercise, this is what it should look like. Essentially, we just want you to grab that text. This is just from the home page, that first page. Then we want you to get the names of all the authors on the first page. So a quick little hint here, notice that I'm using a set, not a list. Next is to create a list, this is specifically a Python list, of all the quotes on the first page. So we want you to create a list that looks something like this. Next, we want you to inspect the site and then use Beautiful Soup to extract the top 10 tags from the request text. So essentially what we want you to do is, if you notice on the home page, we have these top 10 tags. We want you to use Python to figure out how to grab what these 10 words are. So eventually you should get something that it can either be a list or a string or just print it out, but we want those actual tags. After that, we have the final task, and this final task is kind of a larger one. But basically, you'll notice that there's more than one page, and the subsequent pages look something like this. Let me zoom in so you can read this as well. They have quotes-to-scrape.com / and then page / the page number. So we want you to use what you already know about for loops, string concatenation, and everything you've learned through the course to go ahead and loop through all the pages, and we want you to get the unique authors, but now on the entire website. The first question was to get the unique authors on the home page, but now create a set of the unique authors on the entire website. Now keep in mind, there's lots of ways to achieve this, but what we want you to do is try to make your code robust enough that it would work regardless of knowing how many pages there were beforehand. Now, as a hint, we want you to know that there's actually only 10 pages on this website. So if you come to quotes to scrape /10 and then try to hit next, there's no next button there. And then if you try to go to a page that's larger than that, such as /100, you'll notice it'll say no quotes found. So that's kind of a big hint on how you can try to solve that problem. So if you want, you can just use a for loop that goes from page 1 to 10, but really try to challenge yourself, because in a typical situation, you won't know how many pages of quotes there are. So see if you can figure out how to make your code robust enough in order for it to work, regardless if you knew how many pages there were. Last thing to keep in mind is there's many different types of solutions for a lot of these things. So don't feel that you need to check if your code is viable if you figured it out differently than the solutions notebook. As long as you get the same results, then you should be good to go. So lots of different ways to solve all these problems. All right, best of luck. We'll see you at the solutions lecture. Welcome back, everyone. In this lecture, we're going to work through some example solutions for the web scraping exercises. Let's get started. Okay, so first things first, we wanted to import any libraries we think we needed, and hopefully you're able to figure out that it's going to be the libraries we were working with, which is import requests and import BS4. Next, we wanted to use the requests library in Beautiful Soup to connect to quotes-to-scrape.com. I'll go ahead and open that in a new tab just in case we need to reference it later. But you should be able to then just make a request by saying something like results or res is equal to request.get, and then we'll say pass in that URL. Whoops, make sure we actually copy this first. So I'm going to just copy this and then paste it in as a string. So we run that, it makes the request, and we can then view the text. And this is essentially the same document that we had here below. All right, now the first real task is to get the names of all the authors on the first page. So as I mentioned in the overview, notice that this is actually a set, not a list. And that's because if you look at quotes2scrape.com, there could actually be repeat authors. So that means we don't actually just want to go through and grab every author name and then just add it to a list, because Albert Einstein is here twice. So we don't want to list Albert Einstein twice. That way, I can take advantage of a set in order to not even worry about adding duplicates to a set, because a set is just unique items. So what I'm going to do here is I'm first going to create a soup using BS4, beautiful soup. I'm going to pass in res text and then LXML. And now I have this soup. And what I need to do is figure out from the soup what is the correct class call or tag call in order to grab those authors. So one way to do it is by scrolling through this soup and trying to figure out, if you see Albert Einstein, what class call he has. And you'll notice here that there's actually a connection here, class is equal to author. So that may be a good place to start. You'll notice J.K. Rowling as well, class is author. Or you come to Quotes2Scrape and then right click on this name, hit inspect, and then you can inspect this yourself. And it looks like this does actually have class equal to author. Let's go ahead and use that and see if it works. We'll say soup.select, and since it's a class, we'll say dot author. Let's go ahead and run that. And it looks like it's working. We have Albert Einstein, J.K. Rowling, Albert Einstein, Marilyn Monroe, etc. Now, I just want the unique authors, so what I'm going to do is, in order to get this set list, or excuse me, this set, what I want to do is say authors is equal to an empty set, and then I'm going to say for name in soup.select author, go ahead and say authors add, and the name is this entire thing here. What I really just want is the text in between the tags. So we saw in the lectures that I can grab that with name.text. So I run that, and then I can get back the authors that are on the first page. Next task is to create a list of all the quotes on the first page. So similarly, we already have our soup created. What I need to do is figure out what the actual class or tag call is. So I'm going to come back to the website, going to right click on one of these quotes, hit inspect, and you'll notice that it looks like the class call is text. So maybe this is the class call we can use. Often you have to experiment. So let's go ahead and try it and see if it works for us. We'll say soup.select, and we'll say dot because it's a class call, dot text. We run that, and it looks like these are all the quotes on the page. So we have a day without sunshine is like, you know, night. At the bottom, funny quote by Steve Martin. And then the first quote, the world as we have created it. And we see here, the world as we have created it. Okay, perfect. So that means I can simply do sort of same loop. So we'll do the following. We'll create a list for the quotes. We'll say quotes is equal to an empty list. And then for name in soup.select text, or excuse me, for quote, let's go ahead and change that. For quote in soup.select text, say quotes, and I'm going to append, since this is now a list, the actual text there. And now when I call quotes, I get back a list of all the quotes. Perfect. Okay, next we want to inspect the site and use Beautiful Soup to extract those top 10 tags. Lots of different ways you can do this. Main way though is that we need to figure out what the actual tag or class call for those top 10 tags is. So I'm going to right click on one of these, hit inspect, and you'll notice that there's this class tag, but if you search a little deeper, you'll notice that these tags, if I inspect them as well, also have that class tag. So what I need to do is figure out what class do the top 10 tags have that these tags do not. So if you just say tag, you'll get every tag on this page. That's what makes this a little tricky. So I'm going to inspect this again and see if I can find something that is a little more detailed. And you'll notice that up here we have a span. which is tag-item. And if I were to inspect the original tags again, I actually don't see tag-item anywhere. So let's go ahead and give tag-item, that class call, a try, since that looks to be only appearing in the top 10 tags. So I'll hop back over to my web scraping notebook, and I'll say soup.select, and I don't just want to use tag because all the tags on the page had that, but instead I'll use tag-item. Run that, and it looks like it's 10 of them, so let's go ahead and check the length. And it's 10, which probably means we're matching up, and if you were to compare the words we get back, the whatever friendship, friends, truth, etc., those are the top 10 tags: love, inspirational, friendship, friends, etc. So what I need to do is just figure out, either you can append this to a list or you can just print them out. Doesn't really matter. So we'll say for item in soup.select tag item, go ahead and say print item.text, and you run that and you get back these results. If you wanted, you could have saved this to a list and just printed out the list. Main thing you had to figure out is that it just wasn't tag, it was tag-item. That's the main trick. Okay, so we have those. And finally, your task on the last one is, notice there's more than one page, so there's subsequent pages. And what you need to do is use what you know about for loops or while loops and string concatenation to loop through all this to get all the unique authors on the website. So similar to what we did up here, grabbing all these authors, except we need to do it for all the pages. And what we want you to do is try to make it robust enough so that it would work regardless of how many pages there were. So I'll first show you how to do it using a for loop where you knew there was 10 pages, because that's kind of the easier way to do it, and that's more similar to what we did in the exercises. So I'll show you that first. Keep in mind, many different ways you can figure this out. I'm going to just create a base URL to work with. So I'll say URL is equal to, and then let's go ahead and grab this here. I'll say it's equal to http://scrape.com/page. Copy that. I'm going to stick that into a string. And so there's our base URL. And what we can do now is say URL plus, and then concatenate it with kind of any number we want. And then we'll concatenate it at the end with that number. If you want, you can also use .format or really any sort of string interpolation to stick a number in there. So now what we're going to do is simply say authors is equal to set, and then for page in range, and I know there's 10 pages, we'll say the page URL is equal to URL plus the string version of that particular page. I can't just add an integer to a string. I have to convert it first to a string in order to perform that concatenation. Then I'll make the request for that page. So we'll say requests, get the information off that page URL, and then we'll say soup is equal to bs4, beautiful soup, res text, LXML, just as we have before. And then I'm actually just going to copy and paste what we had up here for name in soup.select author, authors.add name text, because we're doing the exact same thing, except now we're just doing it for 10 pages. So this was just for the home page. We're going to set this all up for all 10 pages. We'll go ahead and run this. And then once it's done running, we'll check on what authors looks like. And keep in mind, depending on your internet connection, that may take a little bit of time to go through the 10 pages. But notice here, now I have all the authors. So Marilyn Monroe, Mother Teresa, etc. So these are all the authors on all 10 pages. This is kind of the easy solution because this assumes that you know how many pages there are. Realistically, however, you're probably not going to know ahead of time how many pages there are. So what you have to figure out is what happens once you reach a page that doesn't have any quotes on it. And an easy way to do that is to come back to the website and just, if you keep hitting next, request a page that you know is outside the range. So just, for instance, fill in a bunch of 9s here, and you know there's not going to be 9 billion quotes here. And you can see that there's no quotes found when it hits a page that is outside its range. So that's a very interesting fact to know. What we could do is just keep looping through pages over and over again until we hit something that says no quotes found in the text. So what I mean by that is, let's go ahead and make a couple new cells to work with here. I'm going to say my page URL is equal to that URL plus string version, and let me just put in just a bunch of 9s there. So I know this page shouldn't have any quotes on it. Let's make a request on it. We'll say request.get the page URL. Whoops, convert it into a soup. BS4 beautiful soup. And then we'll pass in res text and LXML. And now if we check out that soup, this is for a page URL that shouldn't have any sort of quote. So there's not 9 billion quotes or whatever. You scroll down here and notice we have no quotes found. So what I can do is simply the following. I know that result.text is essentially a giant string. And so if there's no quotes on that particular page, I can simply do a string check of no quotes found, exclamation point, which is the message shown once there's no more quotes left. So if I run this, I get back true. And now I have a Boolean condition I can check for to keep running my loop. So let's go ahead and set up a loop. We're going to do the following. We'll say page still valid is equal to true. And we'll change this to false depending on the result of no quotes found. We'll say authors is equal to an empty set, so reset it. And we'll start on page equals 1. And we'll say while page still valid, we're going to keep doing what we did before. So we will reset the page URL is equal to URL plus string of page. So this is going to concatenate that new page. And then what I'm going to do is at the end of this while loop, say page is equal to page plus 1. So this is important to keep basically going up that page counter. So we start off at 1, get that URL. We're going to do some more code here. Then next page is 2, do some code again, 3, etc. Next, we'll go ahead and obtain the requests. And so we'll say request.get page URL. Now you may think the next step is to start turning this into a soup and checking if the authors are there. But keep in mind, we have to check if this is a valid page because we don't know yet if we hit no quotes found. So I'll have a simple if statement here. I'll say if no quotes found in res.text, go ahead and just break out of this. Or I could say page still valid is equal to false, depending on how you actually want to break out of this while loop. But essentially what I'm saying here is we're going to reach a page number that's high enough where the string no quotes found will be in the resulting text. And if that happens, break out of this while loop because we're done. If that does not happen, then we'll just continue. We'll say soup is equal to BS4 beautiful soup, just as we did before, text, LXML, and then we'll run the exact same code as before for the authors, which was this little snippet of for name and soup to select author, authors.add. So we go ahead and paste that here. And then once that's done, we go to the next page. Keep in mind, lots of different ways you could have done this, but this is just one valid way. So I'm going to run this and make sure that when I call authors, it matches the authors I had here on the manual for loop. So we'll come here, run authors again, and recall we reset authors. So the fact that it has all the authors here means that this loop worked. Okay, so that's it for the exercises. Hopefully you're able to figure out how to code web scraping applications so that they follow along more like this second part where they're more robust to unknown conditions of a website versus the first one, which basically requires you to figure out how many pages there were to begin with, which for a very large website may be difficult to impossible. So instead, see if you can always figure out a workaround because when it comes to web scraping, the more robust the better, especially since sites can change quite often. Okay, thanks, and I'll see you at the next one.